Okay. I restarted the stream so that I could adjust my well, originally I did it so that I could adjust my my aspect ratio because it was only the it was only filling part of the stream window. And so I needed to update it, and you can't change that value while OBS is running. Okay. Thank you for your patience, even though this is like the second time that I've had to install this stupid freaking thing. This is probably going to be a little bit of a short one, but let's see. I want to open a project solution. Here we go. Why? This is not the right. Nope. Not the right open project. Was there one that was like I feel like here we go. Source. Here we are. It's not where I like this. I like this over here. Yes. And this over here. Okay. So we were at the so it's I'm just gonna this is gonna be a somewhat of a short stream, I guess, but I want to at least want to outline like some small goals here. So like, let's see. So let's we'll just do we'll do animation of blue cube, and we'll do something like update shader values, color, and okay. So we'll just try to do these three things today because these seem all reasonable, and we can do it within our same little loop. Because part of this is trying to understand, number one, when like OpenGL can make things really nice in terms of how quickly you can throw things together, especially with these wrappers that create windows for you and all this stuff. I mean, like this program is actually doing a ton of stuff, but most of it is being abstracted away by SDL and this other guy's library that kind of uses SDL. So, like, what I want to get kind of a grasp of, and like one of the things I think is hard to do, especially because OpenGL is a C-based API, and we're in an object-oriented managed language, it's going to be, it kind of poses a problem. I know this from being traditionally an object-oriented programmer, but I've spent so much time in C++, which you could consider object-oriented. I mean, it certainly would be in that classification, but compared to Java and C# and some of these other like managed object-oriented languages that came later, C++ is very much difficult in terms of designing in a very robust object-oriented way, simply because of things like memory management and having to drag along legacy C APIs like OpenGL. And so what we really want to do is kind of capture exactly how we want to design the architecture around OpenGL, such that we're not going to be limited, you know, to being kind of strangled by this legacy C API that we have, that we're kind of dragging around. So part of that is just kind of determining dependencies, figuring out how to motor pieces of the game, figuring out how to basically abstract all these things into objects and design that we want to use for a voxel engine. And so we're kind of just starting out in general here. We don't even have a concept of a voxel or anything like that. We're just rendering this cube, the single cube, using a shader and a projection and view matrix here. So so the first thing on the list, I think I wrote animation. So let's not move anything yet. Let's rotate the object, or let's pretend to rotate the object. So this rotation here, let's make this guy, well, let's see if we're creating that rotation every time. Let's see what else this guy has on him. So good. There's a I wonder what that is. Create from axis angle, set matrix, swap rows, blah, 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 blah. Okay. So let's pick like an increment. I think we could do this. Let's make this rotation matrix scope to the class. I kind of feel like this is wrong, and my linear algebra is slipping from me. So let's do this. Let's was this this is radians, single precision floating point value. What is rotation? Angle. Radians probably. We'll see, I guess. So here's what we're going to do first. So this rotation is going to end up being, actually, we're not going to do this right now. So we're not going to apply that yet, and we're just going to apply it later. So what we're going to end up doing is we have this position, and we were just kind of statically applying a rotation right here, and then we were just showing the cube. But what we really want to do is come in here, and each frame we want to take, we want to create a new rotation, and we're going to base it on this plus equals 1.1 f. We're going to base it on this angle that we're going to increment. Let's increment it by like 0.05 because I don't really know what it is yet. We're going to figure it out. And then also this axis we can move here because it's not changing. So we're going to call let's see, vector 3. We're going to call this rotation axis. And we can just assign it there. We can just keep that right there. On render frame. Well, they're technically the same thing, but like, I mean like Minecraft blocks. I mean like symmetric cubicle blocks. Like what? 6 sides, 2 triangles a side. That sort of thing. Shared vertices. So create rotation. We're gonna rotation axis. We're gonna pass that each time. We're gonna update the rotation, and then the tricky part is that we need to. Well, it's not really tricky. Is that once we create this rotation, we want to actually that's going to be the same every time too. So let's also create matrix 4 and call this the translation matrix, since we are not technically moving this thing around translation wise yet. We're just going to create it there and pass it there. Projection matrix I don't think changes. That's constant, at least in our case right now. Translation matrix. So here's so each time we come through, we're going to create a brand new view matrix, and it's going to be translation matrix times this new rotation that we have. So this is basically just going to take the existing translation matrix we have. It's going to create a new rotation using our updated value around that 0 or that -1 axis. What was that axis? 1, -1. So positive x, -1. I don't know why that. I guess the -1 would flip the rotation to away from us, or or clockwise. Okay. So what would you refer to Minecraft blocks as? What is the proper because I thought Voxel was more abstract than that. I didn't think it actually had to represent any sort of pixel or anything like that. I thought it was literally just something that was part of a volume. Like a any sort of volumetric entity. Anyway, I suppose it depends on your background, really, because I think I 100% agree with your definition, but I also can see where you could consider Minecraft blocks also voxels, unless You know, I mean, the thing is it just depends on how complicated it is. Because like when you generalize something like a voxel as a bunch of things, it can take away from the other things. So don't let me do that. I do want to get it right. So at this point, model view matrix, we want to update our view matrix, and we're going to update our view matrix to this new you got it. You got it. Yes, that's it. You just don't have enough strength to two-hand the weapon, but you definitely got it. That's definitely the legit move swap. Dude, good job, man. That's really hard to do. I swear, doing it with like a lot of armor on is a little bit easier. But that's definitely the move swap. You got it, dude. All right, so we're updating our rotation, and really and truly, this will become a bigger deal later. It's not going to be a big issue now, but these matrix structures they can be costly, just because of the upfront. Number one, the calculations are not super cheap, but they're not also super expensive either. But like, if you want to, I'm not gonna, and again, I'm a strong believer in write first, optimize later sort of thing, but don't skip the optimization. But when it comes to micro optimizations and stuff like that, it will become a problem, because as we start, especially in a managed language, when you start dealing with lots and lots and lots of geometry, the garbage collection will become an issue at some point. I've had horrible experiences with this, and just most of the time they involve just a simple step, like instead of like pooling an array or something like that. So instead of making the array available for garbage collection, you just reuse the same array and you just copy things into it. You just basically make the most of your objects when you have them. Yeah, it's very true. It's very true. So that makes a lot of sense, especially because you're talking about especially the detail about a single color. So yeah, I mean, so basically it depends on how you look at it, because if you're looking at a chunk, which I think in Minecraft, what'd you say, 16 by 16, is that normal? Or are you just talking about the individual blocks? Yeah, yeah. Well, and especially because optimization is generally less readable. Okay, so what's really interesting though about that is if you start looking at it in a sort of like, the thing that always comes to mind when I start thinking about that or about that description of pixels, voxels, chunks. And by the way, I hate the word chunks, so I'm going to be trying to come up with a different a different name for that existing terminology. But a chunk is basically 16 by 16 Minecraft blocks, I think. Or maybe a chunk is like, I don't know how Minecraft does it. I'd have to research that a little bit, but 16 by 16 chunk seems kind of correct, but I know that since they have height, like y-axis limitations in Minecraft worlds, I think that there's like 16 by 16 by like 64 or something. Yeah, exactly. Chunk is a very physical descriptive word. Holy moly, 256. Okay, so all right, so yes, yeah. So that makes sense to me. Why they would do that? Because they have a finite height. They don't have to worry about expanding much in the height. So what is the max? what is the max height you can go? I remember at some point in their development, they like altered the run length encoding or the save format or whatever to support taller worlds. I can't remember what the this definitely becomes like a data compression issue. I know those guys do a hell of a job of compressing all that data. I don't really even I haven't. It's been a while since I've like cared to know any of that stuff. Well, it seems like when I'm working on this, it's gonna have to be something. I'm gonna have to look at some of this stuff a lot more often. All right, so view matrix. We're creating a new view matrix every time. So we're rotating this blue cube on this XY axis, and we're updating it. I guess we're going to figure out what unit this is right now. And then we're updating this, and I wonder if we have to do, I don't think we have to do anything else. I think we just have to update the shader values and render and see what happens. Yeah, absolutely, man. Post a link, please. So we are rotating. We are not, we're not, you know what? Let's just rotate it on the y-axis. We're not throttling our frames at all, clearly, because we're just absolutely blasting through them. Let's change the axis so that it's something more reasonable here. I have it offset. Okay, so what's happening? The reason why this looks like it is because we are sitting. Let's see, where's the camera sitting? Oh, we're rotating ourselves. We're rotating ourselves here. We're rotating ourselves around. These are always super annoying problems to think about at first, and then as you start working on these things, they start to become more natural. So let's see. I guess I'm sitting this thing. I am sitting this object at -10, and it's rotating around it's rotating around the origin, I think. This is a min and a max. It says it's sitting there. Let's yeah, we're rotating ourselves. We're rotating the view matrix. We're not rotating the object. And in a weird way, it kind of makes sense. So I wonder if we do, as long as we're doing this, it's always going to look like we're just spinning around. I want to see this. Yeah, I want to see that chunk format while I'm trying to like think about this and not feel like an idiot. It's just been a long time. So in order to actually like rotate the geometry, I think that give me a second. Fall distance, fire, air, on ground, no gravity, dimension. Wow. Is it still run length encoded? Interesting. YZX for compression format purposes. It also, yeah, okay, so it is still like it's like a tag based. NBT, is that the old one or is that the no, that's a new one. Level chunk data. X post, Y post, last update. Yeah, dude, look at it's really neat. That the move swap. Look at doing it with some interesting weapons. It's pretty neato. Okay, so I have to revisit my linear algebra, of course, here. Do, 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 do. Is material living in a material world? So I believe the idea is that we will need God, it just really has been so stinking long. This is why I'm doing this project, to really half view. What is the geometry? So I think that's it. I think that's a. I think it's definitely worth it to start that approach. Uh, it's it seems so cut and dry because of the way that the semantics of an octree line up with um like voxels, and how the whole MIP mapping sort of effect, or the level of LOD or whatever, how you can slowly focus into more granular tree data and then zoom out to more so hold on one second. So one of the things that I'm really wanted to see here, it just, I've tried to do it on multiple accounts, and I think it may be due to the way that I start implementing something. I started implementing it and it just didn't really fit the model later. Like I went back and tried to add in Octree, and it just didn't really fit that well. Yeah. That is really neat. That is a shit ton of voxels too. But this is probably this looks like a very octree approach because of the LOD and how things blend and all of that good stuff. So like the trick with the octree is you need to be able to represent multiple voxels from far away as a single entity, right? So like if you have a bunch of multicolored voxels and you zoom out or you become distant from them, you want your level of detail. You don't want to be rendering the geometry for every single voxel at a distance. So you have to find a way to take the reduced, basically one of the parent nodes of the octree, and be able to display it and have it look accurate. And that's really where the challenge is. So, all right. So the idea is we really want to just let's see if I can figure out what I'm doing here. I really just feel like I should get out the old trusty OpenGL beginner's guide because I'm feeling super slow this morning. Da, 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 da. Yeah, dude, it definitely is a start. I mean, the custom map library is the custom map library is so when I did a version a proto. I was talking the last time we did this stream. I did a prototype before I decided I was going to stream it and do it in CSharp. I did a voxel engine prototype in C++, and in OpenGL. And I rolled my own math library, and I will not be rolling my own math library for this. But and I don't want to discourage you from using your own math library. I think there is a lot of knowledge there that you can gain, and I think it's super helpful. But if you do decide that you've had enough of the math library stuff and you wanna use a really good one, and C++ GLM is really good. It's really good. And in fact, I think it's very much a standard in terms of let's see here. Yay! Let's see here. I need to figure out what I'm missing here because I think I think that we just need a different shader. Let's do... No, we don't need a different... No, we don't. We just need to apply the geometry to the the geometry. That's all we need. Okay, so I wonder how much this API supports. So let's see, like, where is this cube VAO? So what does this guy let me do? Not much. So the reason why I'm a little bit confused here is because I expected this to rotate around in the same position. Yeah, I ended up with with a math minor, but that was a long time ago. A long time ago. Yes, you're exactly right. Thank you. Thank you. Let's call this the view matrix. That is what it is, right? Right? And no. What is in position? That must be something. I think actually combining them is okay, right? Is that a standard? Yeah, I mean, I know it's the vertex position, but what I'm confused by is what's passing it. And I assume that it's probably the shader implementation is using that specific. Right. Well, that's what I guess that's what I'm saying is, like, is there any benefit to doing it on the CPU? Because I think I mean, we can combine, like, I think that doing this. That's interesting. I would not have assumed that at all. So let's move back, and I want to see. That thing is moving so fast. Let's do something like, let's see. We'll just do like last micros or something. I need to remind myself here. So we want to capture. I think we can use something like do we want to use stopwatch? I think the daytime UTC, at least for our current setup, is fine. It's probably fine. Oh, we'll just do now. For some reason, I thought. Maybe I'm wrong. I know we can use a stopwatch, so let's just do that. Actually, I think there's a static start new. And we'll say like for our current time is stopwatch dot elapsed. We'll do milliseconds. And if last update equals -1, last update equals current time. Why did it autocomplete without? Oh, okay. No. I see what you mean now. Yes, for the voxel purposes, we will actually put the geometry where it needs to be. Right. So the vertices will actually exist where they should be. Not projected. Not like moved and projected. Like I think that's the problem that I'm seeing right here, is that really what I was hoping is that I could modify this. But it doesn't look like it gives you any access into. It doesn't look like it gives you any access into it. You're right. I totally see what you mean. Yes. I get it. And I also would agree that is faster and more efficient. Why is it irritated about this? Bull? Oops, that's a property. Do I have another last update? Oh, wow. 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 That's why you use Yoda notation. Jesus. At least it explained it to me. God, like C++, I would have been looking for that forever. I think actually, you know what? I think this is fine. We can do this. We can just do 0, and then we don't even need to initialize this thing. We can just say I do know that like per second time span frame length or frame time. We'll just say time span. Why is it not giving me code completion here? There. Thank you. From milliseconds, well, what? We could do like 16. 16 is like 30 frames a second, somewhere around there. So if minus last update is so we don't need to use the time span. We can just use along there too. Is greater than frame time. We'll do greater than equal to as well because that makes more sense. Actually, we'll do less than, and we'll just continue. And this should slow it down a little bit. Or not. Oh, I gotta update the time. And say last update. Last update equals current time. Hey, there we go. So it's definitely rotating around me. What I really need to figure out though is how do I create It was a typo, man. Go easy on me. Go easy on me. So yeah, so that's really what I was hoping to figure out here, but it looks like I'm not going to be able to get to it today. But I'm gonna prepare a little bit before next round because I think my assumption was going into this I would just automatically know how to do it, and my brain is clearly lagging behind today. Well, yeah, I mean we're moving the entire projection. I mean it's basically we're rotating the camera, not the object. Because the geometry is staying the same for the object. We're not touching the geometry for the object. We're just rotating ourselves. Good, dude. Bo, you should start speed running then, bro. So that's essentially what we're doing. We're taking this rotation each time and we're creating it, and we're basically taking the translation and we're just rotating ourselves around, because this API, I don't think it allows you to it doesn't allow you to update. Oh, that's a vertex buffer object. So yeah, I'm gonna actually, so what I would actually have to do is figure out a way how to second, I'm trying to figure this out. So OpenGL definitely supplies a well, I was thinking it provided a way to so the way you would do this in OpenGL is you would have a vertex. You basically have like an array buffer, a GL array buffer, and you would upload GL buffer data. That's basically, you would have to update the buffer data, the vertex data, and also the vertex indices. What I'm trying to figure out is, okay, here, there is a way. If you initialize it as GL dynamic draw, you can actually update it by just re-uploading buffer data. That's basically what we want to do here. We want to keep the same like array buffer with the same number of indices and the same number of everything, but we want to be able to update the vertex data for it. Yeah, basically. Basically, I really want to just be able to create a new I'm gonna have to look more into this API because I need to figure out exactly how to do that, because what I really want to do is when I rotate an object, I want to be able to update the vertices, the end vertices, right? Like that's what we want to change. And then we want to apply our camera projection to the vertices, to the new vertices or whatever. Well, so the issue I'm having right now is that basically I am applying it, but it's rotating around, it's rotating the camera projection and not the cube. I think in order to do what you're saying, we would need what, another shader program. Is that how you do that or no? I don't know. I don't remember anymore. I'm very much I've very much forgotten a lot of this. You guys are killing me. You guys are jumping straight in for the kill here. No, I don't have, and I'm starting from scratch. The point is to understand this before we move forward, and not just like have a camera object that magically does everything. Like we want to. I'm wanting to start from the basics and move towards creating a camera object and creating these things as we go. Yes, no, I understand that you can separate the two matrices, but it in the end it doesn't change the math involved. Like you still have to multiply all of the vertices from the geometry by that projection in order to see it properly on the screen. That's why if you have your projection in your view matrix, then basically the model matrix is gonna, I mean, it's always gonna be the same as well, right? The model matrix is always gonna end up being your view matrix times your model matrix times your model view projection matrix. It's all gonna end up having to be applied. Or are you saying apply it first? And okay, so let's try that. Let's just try that. I think I hear what you're saying. So let's separate it. Let's say there's let's say the model view or the model matrix, and I think you may be right. And view matrix. And we will say what? We want to apply, so we'll say map 4, we'll call it applied model or something, and we'll do, remind me math people, it's model matrix times vec4 in position. I think this is gonna, I don't know, man. Yes, no, maybe, kind of, perhaps. And we're gonna set this is 10. We'll do this as 2. This is actually gonna be our position. This is not gonna change, but what we do want, I'm just gonna do this as quickly as possible because I actually have to go. But let's see. So create translation. We're going to set the view matrix as what? We're going to set it as, we'll just put it at the origin. Why is it mad? Oh, interesting. My eyesight is failing these days. And so actually what we want, this is going to be the model matrix. And we're going to do this. We're going to do it from the origin times the rotation. And we're going to say model matrix is equal to this. So view matrix, all of this is staying the same. And we're crashing and burning. Well, no. Look at doesn't define your camera. It's just a default position. We're starting at -z and we're looking back at the. We're looking back towards the. What did it mean? It didn't have an in position. Did this fail to compile? It did. But why did it fail to compile? Is my GSL? Oh, thank you. Well, that still should be fine, right? Yeah, matrix times a vector is a vector, but was this still should be right? Matrix times vector. Thank you. Thank you. Clearly, that's not what I wanted. Yeah, it's just going to keep giving me the same thing, although it is very curious why that's happening. Okay. So I don't think that we need the translation here. Oh, my shitter's blowing up again because something happened. What did I not fix? Okay. This is what's wrong. Look at there. Yay. Hey, good suggestion, man. Thank you for setting me straight there. It's like I said it the first day. I've done all of this stuff. It was a long time ago. I'm going to look like an idiot a lot doing this live. I think it's kind of humbling, and but it's really nice because I think it's really important, especially if you're a student, man. Like, I think it's really important to see people who have been doing this professionally for 10 years, like, struggle with this stuff. Yeah, I mean, basically we could do that. We can do this. So, all right, wait a second. So what we're gonna do is we're just gonna let's make this look a little bit better. So let's put the translation matrix at 0, 0, -10. Are we still rotating? Let's rotate the thing at 0, -1, 0. This is going to put the center at the origin. The model matrix is going to be at the origin. Let's add that translation back. And then now we have more of a slowly, that dude, Henry. But this is more of like what we were going for. And we could make it move a little faster. So like this is more of what we're going for. I was just trying to get it to actually correctly show, but dude, thanks for setting me straight there, cuz for a minute I was super struggling. Like, it's exactly right. Let's see. Blue Spot came in and basically was like, "Yo, quit being an idiot." But I'm glad you guys are helping me out here, cuz I would be a lost dog, a lost cause and otherwise. Hey, yeah, it's like a real voxel now. You're right. Totally, man. All right, guys, I actually have to get to my real job. I'm being summoned. So thank you guys for hanging out. I'm probably going to do another one tomorrow morning. They're not going to be every day, but tomorrow morning I'm probably going to be doing the same thing. We're going to try to move forward. I'm going to actually try to prepare a little bit versus just kind of like showing up here, hitting the start stream button, and then just kind of flailing around for a while. So hopefully I'll be able to like provide some more direction next time. But thank you guys for hanging out, and thank you for the help. I really do appreciate it. Yeah, no light shading thus far, but we will get there slowly but surely. I kind of said this the first day, is this is the sort of project that starts out kind of slow, and then once things start coming together, it really picks up. So it will be slow, at least initially, until we can get some things designed in a way that's going to, help us move forward. So anyway, thank you guys again for participating, and hopefully I'll see you next time. Take care.